Clean Energy 6. In Clean Energy 5, I made a mistake and said 1,000 gallon of water instead of 1,000 gallon of air. Also, at the bottom of these, I thought maybe I should have 1,558 pounds, 271 pounds away for the 25 containers of air I would have. To pull down the 25 containers of air, it'd be on each side with a teeter-totter operation. Even though with a teeter-totter operation, it really wouldn't have any weight, but when one side come down, it would, okay, but when the rings are slid up on one side and the water got under the air, I'd have lifted the air, and when the rings would slid down on the other side, I wouldn't have any lift to the air, so here, the air would come up. You'd have the lift to the rising air. I'd also, after I had the lift to the rising air, the air would also be able to lift the 1,558,271 pounds. Okay, this would come down with the weight within the bottom of this, plus the weight of the water. Now I have to do everything over again because this is a new video. When the water gets under the air will come up. I have a loss of water height to the top that I have to get down to the bottom. That's why I have the weight in here to pull the blue box down. When the water gets under the air will come up. When the air comes up, it will pull this by this by this. It will create a pressure here and a vacuum here. It'll put this down, these rings will be down, push this down, and push this down. Because this air has no lift, this will slide down. When this all slides down, and the way air, it'll bring the water height that I need back up to the top. So I have the water height that I need. I needed a water height because when the water went under the air, I had a water height loss. Okay, every place you see like this gold bar or this gold part is a slide part. So all these parts is where it slides. Okay, when these are rings. These rings slide up and down, allowing the water to get in under the air or not to get in under the air. When the water gets in under the air will rise. When the water can't get under the air no longer has buoyancy and the air will fall. But, okay, over here, I have two of these. They're called power towers. When the water gets under the air will rise. When the water can't get under the air will fall. But water floats in water, so water don't have enough weight to fall. So when the air comes up, this will fall. When this air comes up, this is hooked to this. When this air comes up, it pulls this red box up, creating pressure here. This is the seal. When this red box goes by, when this red cylinder goes by, this blue cylinder, it creates pressure here and a vacuum here, causing this to come down. And the way that this comes down, this would come up. There'd be a flexible connection here, and this would come up because this air here, although this air has already come up, it would, although this here, the weight of here would still be here, and this air would no longer have lift because these are sealed. This air would still have lift, and this is hooked here, so this all would come up. Okay, so this air would still have lift, so this here is hooked here, and would pull all this up. So, even though I have this weight in here, this air here would still have lift and pull this up. I have extra water at the height, at the top. I have more water at the height than the top that I need in play. So, when the air gets back up the top, I can repeat everything that I've done. So, after this is back up, I slide the rings down, and on power tower number 1, and I slide the rings up in power tower number 2, and repeat everything over again. And then I go back and forth, back and forth. Okay, now, if I have 25 of these containers of air. Each container of air has 1,000 cubic foot of air. Each cubic foot of air figures out to about 62,330 pounds of lifting air. I have 4 of them that I use to raise this up, and I'm using 20 of them, or 1,246,616 for energy. The four I use to raise, and the one I use to raise and lower the rings. But I have 25. Now, part of this weight, I wouldn't use complete weight in here. Part of the weight would be used for the boxes, the green boxes around the air, and the rings. I wouldn't necessarily have to have all this weight here in this box here. Part of that weight could be in the construction of this. Part of that weight there could be in the weight of everything else. That weight there wouldn't necessarily have to be in the bottom. Part of that weight could be in the construction of everything. Okay. So, when the air goes up, it pulls. Okay, I think I got everything in this time. I hope I don't have to do another one. Anyway, when the air goes up, I hope that I have 20 containers of air going up. Give me 1,246,616 pounds of rising air, and that part of that weight I can use to pull the blue box down, because when these rings are slid down, although there's no water under the air here, that air there is under this water weight here, and I'm using part of that weight there, and then I have that weight, all this weight here that isn't used. I have more weight there added to come out to this amount here to pull this down. When this comes down, I gain the water height I need for the next operation to pull the air out.